Okay, this is the video for 3.3, the unit circle and circular functions. To start off with, I've got the unit circle drawn out for you. I've got a separate video about how to construct that. If you haven't watched that, you can pause this and watch that. So let's talk a little bit about where this comes from. This is, we've talked about angles in standard function, in standard position plenty. We've defined our trig functions for angles in standard position. So those are angles where their initial side is along the x-axis right here, and the terminal side is anywhere else. Now, by choosing a point on the terminal side, we can use our definitions of our trig functions to calculate the trig functions of our angle. So, for example, the angle of 30 degrees, the terminal side passes through the origin, and this one point I've got graphed, and we could choose any point along that terminal side there to plug into our definitions for our trig functions in order to calculate it. All the unit circle does is it says let's choose a point on our terminal side, which I don't have any of these terminal sides drawn in. Rather than just choosing some arbitrary point, let's choose one that's exactly 1 unit away from the origin. So here's my origin. If I go out 1 in any direction, like I go 1 in the positive x direction, I hit this point. If I go out 1 in any other direction, and I've only got these few points selected here, these black points here, and in blue these are all the other points. So you've got an infinite number of points you can choose here. And for a given angle, all the angles between 0 and 30 degrees, a point, the point on their terminal side that's a distance of 1 from the origin is given by this blue line. So what that does is it makes our trig functions a lot easier to calculate. So if we look down here, you can see what I'm talking about here. So for example, sine of any of our angles, they're defined. This is defined as y over r, where y is the y coordinate of the point on our terminal side, and r is the distance from the origin. So we've drawn this circle. As long as I pick a point on this circle, my distance r is 1. And that means this will always simplify. So for any point, as long as you pick a point on the unit circle, r will be 1. R is the distance from the origin here. And so instead of having to calculate y over r every time, you can just calculate y. You can find y. So sine of theta is equal to just y. And that is an amazingly useful tool. It's very powerful. In the next sections, we're going to use this to graph our functions, which probably sounds scary to you, but it's just a direct result of getting to eliminate one of our variables here. Now I've only got 2 variables to look at, my angle and my y value, or say we looked at cosine. Cosine is x over r. Well, that would just be x over 1, or just x. So cosine of our angle is equal to x. So anyway, our angle, each of those cases, we've only got 2 variables. We'll be able to graph one variable along the x-axis and one along the y. But I'm getting ahead of myself. Let's just focus on the unit circle for now. Oops. So, where was it? Okay. Next up on our guess, a list of things to look at, that should be S divided by R. I need to make that correction. Okay. Alright, our angle in radians is defined as the arc length divided by R. Okay, not it. S times R. So replacing R with 1, since we've chosen R to be 1 everywhere along the unit circle. Well, just like our trig functions simplify, our angle simplifies to be equal to our arc length. So this is an important thing just to help alleviate some confusion. Your book is going to reference things in terms of arc length now, but this is the exact same as the angle. Okay. So, for example, 30 degrees or pi over 6 radians. Pi over 6 radians you could think of as the angle measure, but that's actually this distance right here. If you were to take this blue line and flatten it out, that distance is also pi over 6. Through the miracles of ratios, or through the miracle of ratios. Because this distance to the blue line is always going to be 1. Taking that arc length and dividing it by 1 is not going to change our distance. So again, this will be a useful concept for graphing. To me, that's the most powerful function of the unit circle, is it makes graphing these things possible and kind of easy to visualize. Okay. Now, you can also use this, now that we've talked a little bit about where this comes from by setting R equal to 1. Now we can talk about some of the other uses for this. Again, I don't use this way, but a lot of students do. A lot of students really like the unit circle, so that's what we're about to talk about. So each of our trig functions, I've got newly defined here in terms of that arc length. But again, you can just cross that out and write it as your angle theta. You know, don't let that throw you off that your textbook uses this new letter S. I mean, that's because your arc length here, S, is the same as your angle. Okay, but all of our trig functions you see are a lot easier. There's no r's anywhere. There's just in terms of y and x. So sine is equal to y, cosine is equal to x, tangent is equal to y over x. Okay, so let's look at just sine for now. Sine is equal to y. Now I'm going to go back up to my table because I've got sine and I've got our values for sine at our standard angles, 0, 30, 45, 60, and 90. Okay, so here are the sine values that we know. 0, 1/2, square root of 2, square root of 2 over 2, square root of 3 over 2, and then 1. Now, according to our definition, sine is equal to y. You can actually see that one right here. Sine is equal to y. The sine of our angle is equal to y, excuse me. Well, on our unit circle, we can find the sine value of any angle by looking at the y-coordinate on the terminal side of that angle. So at 0 degrees, our terminal side is right here, and the y value of that point is 0. Right, the ordered pair there is 1, 0, x is 1, y is 0. Well, look, sine is also equal to 0. If we go to our next angle, 30 degrees, the y value of that point on our terminal side is 1/2. Look at that, that's the sine of 30 degrees, it's 1/2. And as you proceed around this circle, you can see this continues. At any point, so at any point for our angle, any point we choose, the y value of that point is equal to the sine of that angle. So sine of 45 is square root of 2 over 2, and that's the y value of our coordinate here. Right, just like in our table, sine is square root of 2 over 2, the y value is square root of 2 over 2. Next up, we've got 60 degrees. The sine is square root of 3 over 2, and we look at our unit circle at 60 degrees, the y value is square root of 3 over 2. So this makes it really easy. If you draw your unit circle and I ask you to find, say, the sine of some angle, like I said, what is the sine of 240 degrees? Well, we would go down to 240 degrees and say, well, what's our y value? It's negative square root of 3 over 2. Well, the y value of that point is equal to our sine. So the sine of 240 degrees is negative square root of 3 over 2. So that's fantastic when you've got the unit circle right there in front of you. So you need to be able to create this circle. And I've got a video about how to make this, how to write these ordered pairs. You see, it's just these same values repeated over and over. These same y's, 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. And then it repeats. Well, it doesn't repeat, it kind of reverses. But again, you can watch that video for how to do that. Next on our list is cosine. Cosine is equal to x. I won't go back up to our table because I've got this thing written here. But just like sine, the cosine of a given angle is it comes from the x coordinate of our ordered pair here. So the cosine of 0 degrees is 1. The cosine of 30 degrees is square root of 3 over 2. The cosine of 45 degrees is square root of 2 over 2. Cosine of 60 degrees is 1/2. So every time we're just looking at that x coordinate. So again, if you've got the unit circle in front of you, I could say, what is the cosine of 330 degrees? And you just look at it, find 330 degrees, and the x value of that square root of 3 over 2. So the cosine of 330 is square root of 3 over 2. Okay, so as long as you can find these two, all of your other trig functions can be written, they can be found using these two. So tangent is y over x. I mean, you could look at your y, divide it by your x, and that gives you the tangent. So for example, tangent of 45 degrees, square root of 2 over 2, divided by square root of 2 over 2. Well, that one's kind of lucked out there. Dividing something by itself gives you 1. So tangent of 45 degrees is 1. These other calculations may take a little bit of pen and paper. But you just find them by performing whatever calculation it says. Y over x, say for 210 degrees, I said find the tangent of 210 degrees. You take your y, which is negative 1/2, divide it by x, which is negative square root of 3/2. And that should give you, well, let's see, a negative divided by negative is positive, so it should give you a positive value. And 1/2 divided by square root of 3/2, I need to multiply by my reciprocal. I get 1 over square root of 3, because my 2's will cancel. Okay. So, I mean, there's not a whole lot to really say other than that. If you can draw this out, the important thing to realize is that the x and y coordinates are these x's and y's in your definitions. So if you want to find secant, you're going to have to take whatever x value you're given and flip it upside down. Take the reciprocal of that. So I guess I'll do one of those real fast. Secant of some, let's say secant of 300 degrees. 300 degrees is right here. Is that right? This is 300 degrees. Okay. The x value for that is 1/2. The reciprocal of 1/2 is 2 over 1, or just 2. So these cosecant and secant are also much nicer. All we do is take whatever fraction you're given and flip it upside down. That should be not too exciting. Not a lot to that. So a lot of students seem to prefer to use this unit circle. I always, I always like my table. So there, if you're used to doing this, there's no reason to go and memorize this unit circle. You can do all of these things, using this table, as long as you can find your reference angles. Okay. This is just another method to do what we've been doing all along. In fact, all of this next part, finding a number, either your arc length or angle, whatever you want to think of it as, when given the circular function value. So example, okay, for this we would need a calculator. Okay, but like this, where is tangent equal to 1? Tangent is y over x. Okay, and they say between pi and 3 pi over 2. So there's pi, 180 degrees. 3 pi over 2 is right here at 270 degrees. Where in here is tangent equal to 1? And we actually just did this. We kind of did this. Right here in the middle, we see our y and our x are the same. Tangent is y over x. So we take negative square root of 2 over 2, divide that by negative square root of 2 over 2, we would get 1. So that's the angle we're looking for, 225 degrees, or 5 pi over 4. Okay. Again, we have other methods of doing this, and you can just write this in terms of degrees, if you don't like dealing with the radians. You can, for these at least, when you've got a decimal value here, you could just plug this into your calculator. Now, this is a kind of weird example right here. I don't know that I even will give you any like that. A better example would be, say, find your angle or find your arc length. If, let's say we said, if cosine is equal to negative square root of 3 over 2. So let's see, where here is cosine? Cosine is my x values. Where is that equal to negative square root of 3 over 2? Well, there's 1. There's an x value. We've got negative square root of 3 over 2. Do I have another one? Yeah, there's another one. So those two angles both have an x value of negative square root of 3 over 2. So 150 degrees or 210 degrees. In radians, 5 pi over 6 or 7 pi over 6. Okay. Gosh, is that really all there is to this? Well, okay, I guess that's it for our introduction